Welcome back guys to another video. In this video we'll be covering implicit differentiation. So let's start off with a little review. So first let's cover the difference between explicit and implicit differentiation. So to begin with, explicit differentiation pretty much means that y can be written as a function of x, which essentially means you can solve for y. So some examples of this include y equals 2 over x cubed, or x cubed times y equals 2. And then if we're talking about implicit differentiation, it pretty much means that y cannot be easily solved for. So let's write that in. Implicit means that y cannot be easily solved for. And some examples of this are y squared equals 7x plus 2. So for this function right here, it actually can be solved for, but there was really no point in doing that because it would just give you a parabola on its side. So another example of this would be 14 minus 6xy plus 2y equals 7. So right here, this is going to be difficult to solve for y, but yeah, that's implicit differentiation for you. So let's start with some notation actually about this. So for notation, I'll do it in pink. Notation. The notation for a derivative would be something like d, the derivative with respect to x. That's how you pronounce it, the derivative with respect to x. And then let's say we have x cubed. So this essentially just means find the derivative of x cubed. But if we were to be technical, we would say the derivative with respect to x of x cubed. And this is actually equal to 3x squared. And if we use the power rule here, we know that this is equal to 3x squared because 3 times x times to the power of 3 minus 1, so that's 2. And this is actually multiplied by the derivative of x. So the way we can write that is dx over dx, but then that just cancels out to be 1. So this would actually be just equal to 3x squared, like that. So it's 3x squared right here. But then let's say that we're asked to find the derivative. Let's say we're asked to find the derivative with respect to x of, say, 5y to the 8th. So we come across a pretty intriguing problem here. So if we apply the power rule again, what ends up happening is we get 8 times 5 to the, or times 5y, or no, just times y, my bad, times y, 8 minus 1, which is 7, times the derivative of y over the derivative, or the derivative of y with respect to x. So if we were to simplify this, we just get 40 y to the power of 7 times the derivative of y with respect to x. So in this case up here, we get 1. We can simplify this to be 1 because dx over dx is just 1. But in this case, it's actually derivative of y with respect to x, which means that it would just be, we can't simplify it to 1. So let's try one more problem here. Let's say we're asked to find derivative with respect to x of, let's say it's 3x squared y to the power of 4. So if we were to find the derivative of this, we'd have to use the product rule, of course. So let's do that real quick. So our first term is 3x squared. So let's write that in. 3x squared times the power, or times the derivative of y to the power 4. So the derivative of y to the power 4, if we look at the product rule, would be equal to 4y to the cube times dy dx. Derivative of y over the derivative of y with respect to x. And just a side note, this can actually be written as y prime, but I don't suggest you write it as y prime because you're more likely to make mistakes if you do. So let's write that in. 4y cubed, or 4y cubed dy dx. And if we just use the product rule some more, we get y to the power 4 times, and the derivative of 3x squared, which is just equal to 6x. Now we can simplify this. 2, and if we simplify this, we would get 12x squared y cubed dy dx plus 6xy cubed, or to the power 4, my bad. Man, I'm having a rough day. So that's what we would get for this problem right here. Now, let's go on to a little more advanced problem. So we'll need a lot of space for this. So let's say we're asked to find the derivative with respect to x of 5x squared plus 3 cosine of y equals 7. Let's say we're asked to find the derivative of that. So our first step to this would be to take the derivative of 5x squared. So if we were to take the derivative of 5x squared, that would just be equal to 10x, because this would be equal to 2 times 5x, 2 minus 1, which is 1, times the derivative dx over dx, which is 1. So this is just 10x. And our second step here would be to find the derivative of 3 cosine of y. So for this one, we can use the general, or we can use the chain rule. So what the chain rule states is that 3 cosine of y would, if we were to find the derivative of it, it would be equal to, and it would be 3, and now we have to find the derivative of cosine. Derivative of cosine is negative sine. Negative sine of y times, and we have to find the derivative of y, but since we're asked to find derivative with respect to x, it would be dy dx. So we can actually write this in right here as negative 3 sine of y dy dx. And then we have to find the derivative of 7 finally, and since 7 is just a constant, it would be 0. So now the final step here would be to solve for dy dx. So in order to do that, we can first bring the 10x to the other side. So negative sine of y dy dx is equal to negative 10x. And then finally, this would just be equal to negative 10x over negative 3 sine of y. So that's how you find the derivative of 5x squared plus 3 cosine of y equals 7. However, sometimes they might ask you to find the derivative at a certain point. So let's say they ask us to find a derivative, and I'll write the instructions down in red. Find the derivative at, and I'll write the points in green, 3, 4. So, and let's say the function they give us is x squared plus y squared equals 25. So, if we were to find the derivative at 3, 4, what we have to do is do dx, and then we'd have to take the derivative of the equation they gave us. So x squared plus y squared equals 25. And we just solve it normally. So we take the derivative of x squared, that's just equal to 2x. Then we take the derivative of y squared. So in order to take the derivative of y squared, it would just be 2y times 1 times dy dx. So this would be 2y dy dx. And then we take the derivative of 25, which is just 0. So now we have to solve this. And in order to solve it, we can use the steps we did last time. So we go 2y dy dx equals negative 2x. And we bring 2y to the other side. So this would be negative 2x over 2y. And this would just be equal to negative x over y. But now since we are asked to find the derivative at the point 3, 4, what we do here is we plug that in. So the way we show this is we draw a line, and then we write the coordinates in. So I'll write the coordinates, 3, 4. And then we go back to our original equation here, and we just show it like this. dy dx equals, and then since it was negative x or divided by y, we just plug in the values. So x is 3, so negative 3 over, and then y is 4, so 4. So that's how you do that problem. Now, let's say that there's one more problem here that we have. Let's say they ask us to find the derivative and evaluate it at, and then let's say there's some points here, 3, 2. And then let's say the equation they give us is x plus xy minus y squared equals 5. So we have to find the derivative of this, of course. So this would just be d dx of x plus xy minus y squared equals 5. So if we were to find derivative of this, we just find the derivative of x, that's 1 plus xy, and here we'd have to actually use the product rule. So the first term is x, and take the derivative of y, which is dy dx, plus, and we take y, just because the second term is y, and we take the derivative of x, which is 1. Oh, and just note that the only reason the derivative of x is 1 is because this is respect to x. If this was respect to y, so let's say, for example, this was dy instead, then the derivative of y would be equal to 1. Just a side note. So there's that. And then minus, so then this is equal to 2y dy dx, derivative of y. and then 5 is just 0. So let's simplify all this here. 1 plus x dy dx plus y minus 2y dy dx equals 0. So the step that I would do next is I would bring everything that does not have dy dx to the other side. So let's do that real quick. X dy dx minus 2y dy dx. And then this is equal to, so 1, so negative 1 minus y. And then what we do here is I'd rewrite this as x minus 2, or my bad, x minus 2y dy dx equals negative 1 minus y. And we can actually just write this as dy dx is equal to negative 1 minus y over x minus 2y. So now we have to evaluate at the point 3 comma 2, and we'd signify that by drawing a line, then inserting the point 3 comma 2, and this would be equal to dy dx is equal to, and we just plug in the points, negative 1 minus y, so minus 2, x, 3 minus, and 2 times 2 is just 4. And this would be equal to 1. So that's our final answer for that problem. So if you enjoyed this video or it helped you with your homework or math test, please like the video, subscribe, and comment what your favorite part was below. And if you need help on any other math subjects, please comment that below as well. Okay, goodbye guys.